Okay, so we're not going to worry about section 8.5, but this is section 8.6, and it's over trapezoids. Okay, so there are two different kinds of trapezoids. There are non-isosceles trapezoids, and there are isosceles trapezoids. So here are the properties of non-isosceles trapezoids. Only one pair of opposite sides are parallel, so see just one pair, not two like in parallelograms. And consecutive angles are supplementary. This comes because of the parallel lines. Okay, so that means these two are supplementary, these two are supplementary. Okay. Now, for isosceles trapezoids, they have these same properties, but then it has some extras. That the non-parallel sides are congruent. That's what makes them isosceles. The diagonals are congruent. The base angles are congruent. So on here, that would be like this big angle and this big angle are congruent, and then these angles are congruent. And then because we had these consecutive angles are congruent and these are the same, then that means opposite angles are also supplementary. So these angles are supplementary, so these angles are supplementary. Okay, let's try some. So first, we'll find the missing angle values. So we know that if these are the parallel lines, that consecutive angles are supplementary. So if I want to find angle M, I'm going to do 180 minus 87. That's going to give me 93. And to find angle K, I can take 180 minus 51, and that'll give me 129. Go ahead and try number 2 on your own. Number 3, here are the parallel lines. These angles are consecutive, so they're going to add up to 180. That's going to be 54 plus 8x plus 6 equals 180. So that's 8x plus 60 equals 180. 8x equals 120. Divide by 8. X equals 15. And it just asked for x there, so that's it. Okay? Find angle R. Again, these are going to be consecutive, so they're going to add up to 180. 12x plus 3 plus 7x minus 13 equals 180. So 12x and 7x make 19x. Minus 10 equals 180. Add 10 to get 19x equals 190, so that when you divide by 19, x equals 10. Now, doesn't ask for x, does it? It asks for angle R. So we're going to put it back into this angle at angle R. So 7 times 10 minus 13, that's 70 minus 13 is going to be 57. Okay? All right. Now in number 5, we have something special. This is an isosceles trapezoid. That means that these sides are the same. It means that the diagonals are going to be congruent, and it means some other things. So DG is congruent. Now remember, if we have hats on things, when it asks what it's congruent to, we're asking for another segment or another segment. So the side that is congruent to DG is going to be EF. And when we look at DF, DF is the diagonal, so EG is the other diagonal that it's congruent to. Something similar in number 6, okay? Because remember, these base angles are going to be congruent. So T and U are going to be congruent, so we're writing angle U here. And angle W is congruent to angle V. All right. So now we're trying to find, in number 7, we're trying to find all the remaining angles. Okay, so the first thing we can do is come up to our properties. Opposite angles are supplementary, and base angles are congruent. So P and Q are base angles. So angle Q is also going to be 112. Then, because of the parallel lines, we have supplementary angles. So if I want to find angle S, I can say 180 minus 112. That's going to be 58. And I know that S and R are congruent because they're the base angles. Oh, I'm so sorry. I made a mistake. 180 minus 112 is not at all 58. It's 68. So those are both 68. Go ahead and try number 8 on your own. Okay, so in number 9, we're going to say that this trapezoid is an isosceles trapezoid. It says MP is 16x minus 3, so I'm going to label that 16x minus 13. And NO is 9x plus 8. And I'm trying to find x and y, so I'm just going to start with that because these sides are equal and they both have x's in them. So I'm going to set them equal to each other. And I'm going to solve. Seven x equals 21, divide by 7, x equals 3. Now to find y, I know that the diagonals are congruent. So those are the things that they give you. Pn is 5y plus 19 and MO is 12y minus 37. So we're going to put those equal to each other and solve. So when I subtract 5y, oops, sorry, misspelled y. So 7y equals 56, and divide by 7, y equals 8. Now in number 10, we have some base angles that are given. And in an isosceles trapezoid, the base angles are congruent. So let's find x to start off with by setting these two equal to each other. So subtract 2x from both sides. 27 equals 3x minus 12. Add 12. That's 39. X equals 13. So now we'll plug that in to find D. We know that C and D are equal. So I'll just do 2 times 13 is 26 plus 27. And that's going to give me 53. So C and D are 53. Now, A and B are also congruent. The way that I could find A is just to take 180 minus 53. That'll give me 127. And then angle B is also 127. Okay, so number 11. Number 11, this time, these are consecutive angles, so they're going to add up to 180. So 10x minus 33 plus 4x plus 17 equals 180. That's going to make 14x minus 16 equals 180. When I add 16 to both sides, I get 14x equals 196. So when I divide by 14, I get x equals 14. Okay, so now I plug those in those two places. Here I'll do 10 times 14 minus 33, okay, for angle J, and that'll give me 107. And when I plug it in with M, 4 times 14 plus 17, that'll give me 73. And I know that J and K are equal, so K will also be 107. I know that M and L are equal, so those will also be 73. Okay, now on number 12, these are the opposite angles. So opposite angles in an isosceles trapezoid are consecutive, are supplementary. So they add up to 180. 10x plus 5 plus 6x minus 1 equals 180. So that's 16x plus 4 equals 180. Subtract 4. 16x equals 176. Divide by 16, x equals 11. Okay, so now you plug those in. 10 times 11 is 110, plus 5 is 115. 6 times 11 is 66, minus 1 is 65. And we know that x is also going to be congruent, because it's isosceles, and z is also going to be congruent to y, so 65. All right, here we have in number 13, we have another isosceles trapezoid. These are base angles right here, so they're going to be equal. So we have two pairs of base angles, the ones at the top and the ones at the bottom. They're going to be equal. 21x minus 16 equals 18x plus 5. Subtract 18x. 3x minus 16 equals 5. 3x equals 21. Divide by 3. X equals 7. We plug it in. 21 times 7 minus 16. 21 minus 7 minus 16 is going to make 131. And angle D is also going to be 131. To find E and F, we'll take 180 and subtract the 131. So that'll be 49 for both E and F. Go ahead and find your work on number 14. Number 14 and number 12 are very similar, so you can use that as your example. All right, I know, 3 pages of notes. Are you kidding me? I know, it's okay, it'll be fine. So we have one other thing called the mid-segment of a trapezoid. And that's, the mid-segment is if it connects the midpoints of the legs here. Okay, so here's the midpoint. E is the midpoint of AD. F is the midpoint of BC. Okay, and so we have some things that are true if it's a mid-segment. If it's a mid-segment, then AB is parallel to DC, yes, like it's written. But also EF is also going to be parallel. Okay? And then the length of EF is going to be the average of the bases. So AB plus DC over 2. Okay, so we can use this formula in number 1. Okay, it says we're trying to find EF. So EF is equal to 14 plus 26 over 2. That's 40 over 2 is 20. Okay, number 2. EF is 7 plus 31 over 2. 38 over 2 is 19. Now, 3 is mixing it up a little bit. 22 equals AB plus 38 over 2. So the way I'm going to solve this is I'm going to multiply both sides by 2 and get 44 equals AB plus 38. And so when I subtract 38, AB is 6. Go ahead and try number 4. Number 4 is very similar to number 3. Do that on your own. Okay, so now we're going to find YZ, which is your mid-segment. But before we can do that, we have to find the X. So we're going to use that formula again. Okay, we're going to say that YZ, the mid-segment, is equal to the bases 38 plus X plus 14 over 2. Okay, so 5X minus 19 equals X plus 52 over 2. And we're going to multiply both sides by 2 to get rid of that denominator. Okay, don't forget to use the distributive property over here. So we have 10X minus 38 equals X plus 52. Subtract X from both sides. 9X minus 38 equals 52. Add 38 to both sides. That's 90. So x equals 10. And of course I'm not done because that would be too easy. I have to plug it in for yz. 5 times 10 minus 19. Yz is going to equal 31. Okay, number 6. Again, I'm going to use that mid-segment formula and then plug it in to find j at the end. So my mid-segment is 25. That's equal to 2x plus 11 plus 6x minus 1 all over 2. Oh my gosh, look at this Algebra 1 we are practicing. That is so good. I know you were thinking, Mrs. Oaks, please give us more Algebra 1 to do. So this is 50 equals 8x plus 10, subtract 10. 40 equals 8x. X equals 5. So now if I want to find kj, I'm doing 6 times 5 minus 1. That's 29. That's your final answer. Okay, go ahead and use those examples to do number 7 on your own. All right, before we go on, I want to just have you look at this quadrilateral properties. Think of this like a family tree, kind of. Okay, we're going to, I know it's on its side, it's okay. We have special things. We've got parallelograms, is a special kind of quadrilateral with all these properties. Okay, special kinds of parallelograms are rhombi and rectangles, and then kind of that combination of rhombi and rectangles is a square. Okay, and these are all the properties that go with it. Okay, so this is kind of just a good kind of summary worksheet for us over all the things that we've done so far.